recorded live.
Welcome to the Virtualization Security Roundtable podcast episode number 86. Our panelists today are Ivan Rodriguez, who is a cloud security infrastructure architect helping eBay adapt new use cases to their internal and external managed compute services.
Hello. Joining
us later will be Michael Berman, the CTO of Catbird, the pioneer and industry leader in security and compliance for virtual environments. Boris Strongland is a co-founder and currently VP of Advanced Products at High Trust with 20 years of experience in software development, enterprise systems, and security. Myself, Edward Haletke, a.k.a. TechSciWill, on just about anywhere on the net, and I write for the virtualization practice as a cloud and virtualization security analyst. Welcome to the podcast. Now, today's a little different. I want to do this in response to a customer that I had. I was talking to him. I was down visiting them, talking about compliance. And we got a question that came in. It was rather intriguing. It's how do you put or move an existing physical environment into a virtual environment and maintain the same security level? Where do you put the firewalls? What type of firewalls do you put in place, and so forth? I thought it was a little odd until I realized that these people were talking about, they want to take their physical environment, including all the firewalls, and virtualize everything. And then they were thinking, well, how do I put my firewalls in? I can't use my physical ones anymore. They realized that. So now they wanted to use virtual ones.
Well, yeah, there are lots of options that vendors have for virtual firewalls, right?
Absolutely. So, there's virtual firewalls that can be done inline, as in a bump in the wire.
Oh, right.
So between two virtual switches. You have ones that sit side by side with the existing virtual network,
yep,
a la Catbird. You have ones that sit in line before the virtual NIC.
So give us some background. How large an environment is this customer talking about?
Very large.
So they have the option to have separate like management clusters, compute clusters.
Absolutely.
Possibly we might look at doing a DMZ or firewall cluster, right?
Well, I'm not sure even a DMZ or firewall cluster is even worth it. That's what I mean by defense in depth. When we started talking about that, I said, we'll just keep everything separate. But then you think about it this way. Each virtualization host, regardless of virtual machine workload, has minimal 3 to 4 trust zones built right into it. So even if I put those into a DMZ set of cluster of nodes, the management of that is still on a separate trust zone than the workload. And they're going to cross between the DMZ one and another cluster,
so
right? They're going to be managed by one vCenter.
I can share some background on this a little bit. They might. You're right in that they might be managed by one vCenter, but what I've run into in organizations in the past is the answer to this question typically comes up not from technology but from the organizational structure. So the teams that are traditionally supporting firewalls in a team, in a group, in a company, might want to have their own way of doing things. Maybe it's a certain vendor or product line that they're familiar with. They might not feel comfortable using a new tool from another company that's now virtualized.
Absolutely, I agree with you there.
So that's where a lot of times I've seen the decision be made based on what they're comfortable with. So we have to pull different teams in.
But absolutely, the security team needs to be definitely part of this. They need to be at the table when they make this decision. And for these guys, it was like, they asked me, so what do you do? I said, well, first off, I find out what type of firewalls they currently have, what type of big IDS IPSs they have. I make recommendations based on that. Like, for example, if they have Juniper SRXs, go with Juniper VGW. If they got Cisco's, they may want to go with a virtual ASA.
Right, if they're happy with those. Right.
If they're happy with them and they don't want to change, there's upgrade paths for all the major vendors, except for some of the ones that aren't. Some of the newer ones, like Palo Alto, does not have a virtual presence yet.
Right.
Will they? We don't know. So some people went with all Palo Alto for their edge. Why get rid of that? Use it for your edge, but then put something else that would work with it, like maybe some of these other tools.
So for your customer, how'd that work out for him? What were some of the other factors?
Well, one of the other factors was rather intriguing as well, is that they really just wanted to say, okay, well, where do we place the firewalls? We're virtualizing these 700 to 1,000 to 5,000 machines, or whatever the number being. They have what they call their security zones or trust zones that are different than what we were calling them. They didn't even think about the ones that are built into the hypervisor themselves.
So that's another thing, is I found that a lot of the firewall products do not necessarily protect the hypervisor. It's going to be on one VLAN or a couple different VLANs for storage or vMotion or what have you. But the firewalls are protecting, if they're VM safe firewalls, like you mentioned, VGW, they're protecting just the VM guest.
Well, no, a lot of these are protecting just the virtual network or the physical network, depending on how you have it implemented. Think about it this way: can anything really protect the hypervisor? Of course, can you?
Yeah. Who's there?
You guys have a product. You're protecting the management constructs that they themselves talk to the hypervisor.
Absolutely. And
but
there's
the guest
also
itself talks to the hypervisor, but through its own virtual machine manager. So nothing really touches directly the hypervisor.
No, other than the management access, which we protect, nothing touches the hypervisor directly. And on the guest side, I guess my question would be, initially, what kind of traffic they want to protect? What they want to protect against? Is it they want to prevent VMs talking to VMs, unauthorized traffic between VMs? They want to protect unauthorized traffic to virtual switches? What is it exactly that people maybe all of the above?
Exactly. So it ends up being a question of, well, what's the data, right? We want to know what you're trying to protect. And they were saying, well, we got PCI workloads, we have DMZ workloads, we have these workloads, and they're different security zones. And they literally have right now in the physical environment, and they haven't virtualized everything. They've virtualized a couple thousand VMs already, machines already. They got a couple thousand more to do, and then another couple thousand. Then they're going in small chunks of manageable sizes for them. It's a couple thousand at a time. That's still a fair amount.
Mm-hmm.
And they're not thinking introspective yet. They're not going to that point. What they're thinking about is, okay, I got a physical firewall here. I now need to virtualize something. Where do I put the physical firewall again, or can I? Right? Do I need to move to a virtual firewall?
The other thing to consider is topology. A lot of times the internet links come in. Some companies might have them go directly onto the firewalls.
Right.
But if you're in a larger environment like that, it sounds like there'll probably be an external routing network.
You need to have an external physical or a separate host.
Yeah.
Otherwise, it's kind of like having the fat kid watch the pie, isn't it?
Yeah. That's why I was thinking of a DMZ cluster that's isolated.
Okay. When we start thinking about it that way, so they have an external routing network, which is fine. But once you get into the virtual network, and then we started talking about what is the defense in depth that's available. Okay, I can put edge firewalls of various types into my virtual network. We all know there's vShield Edge, there's the Catbirds of the world, there's the Reflexes of the world, the Trends of the world, the Junipers with VGW, there's Checkpoint, there's IBM, there's a bunch of them, right? Then you start thinking, okay, those are the edge firewalls. Well, what else is there?
Well, there's routers. You mentioned an external routing network, but that could be virtualized too now. There's a lot of virtual routers. Viata is very popular. And
also, Viata acts as a firewall. They're a bump-in-the-wire firewall.
It's
edge
not
firewall.
as advanced yet. They have stateful inspection, but they don't have a lot of the more advanced features like Palo Alto have. And I'm sure, there's feature parity coming along, but right now there are dedicated firewall products which are better than dedicated router products, basically. So if you're going to make a virtual routing network, that was where your BGP could happen. You could have your DMZ used for that as well.
Okay. So you could actually virtualize your routing. You can adjunct your existing routing network with a virtual component. Absolutely.
Even that could be replaced. And what we've found for security in larger, say, cloud providers or larger organizations have a very high throughput to the internet. Maybe they're
why wouldn't
consumer
we
facing.
do like route redistribution? And that would
Hold on a second.
Oh.
Hold on a second.
Yeah, I mean, you can do any sort of network.
Can you finish your thought about
any kind of network topology that typically is handled through routers physically could also be done virtually, is what I'm saying. Mm-hmm. And that includes, from security perspective, you need to be able to put ACLs. ACLs are where you would put bogon tables and other blacklists to just outright block traffic that you know is bad. Firewalls are where you allow traffic, say like to port 80 to your web server, but you want to filter it or inspect it. So typically it doesn't have as high a throughput capability. But to mitigate against denial of service attacks, you need to also have a router which has a high throughput capability and the ability to blacklist using ACLs. And larger organizations use routers for that instead of firewalls because they just blacklist it. And then the firewall gets only what is supposedly good traffic, and then it does a deeper inspection on there.
Okay. Tim, your question now?
My
comment?
point was, why could we just do route redistribution, and that would solve the problem too?
Well, yeah, so there's intelligence that you have in your firewall, right? So if you're...
Well, you wouldn't even have to worry about what protocol, whether you're using BGP or, anything like that,
Sure. That's a different network design. That's possible. So I guess what we're saying is that if you rethink your architecture because you're going virtual, you have different options available to you now than the legacy.
Well,
put everything in one box.
So the main point of this one was, do you really need to rethink your architecture? You can, and probably worth it, but do you have to?
Yeah. So and the teams, you might have find this. If you use an existing, well-known architecture, it's easier for the teams to sort of correlate old ways of doing things to new ways. So, like I said, the ACLs on the routers, and layer 4 through 7 deep inspection on the firewalls. That might be an easier way to think about it because that's the way we've always done it. But down the road, as you mature, you might say, hey, we could use our firewalls for this too. We don't need those routers anymore, or vice versa.
Or you could say, I want to put even more defense in depth. So for right now, for the general purpose thing is that when you have a physical network, you have firewalls separating groups of machines. You have the operating system-based firewalls usually on those machines, right? And routing and all that type of thing happens. And top of rack and all those denial service preventers, right?
Right.
Yeah.
So when you do that in the virtual environment, you could literally take all that and still use it today. You don't have to use the physical firewalls, but the big pieces of the big routers that are trying to blacklist things, those are great. Then you have maybe have an edge firewall, your physical firewall. You may still want to have that because of throughput reasons, whatever. And then behind that, you could put a bunch of VMs. Or you can put a virtual switch, then you separate all your VMs off of different port groups, VLANs and so forth, but you could also put in those places. Wherever you had a physical firewall, you could literally drop today a virtualized edge firewall of some form. Exactly the way it was before.
You mentioned switches, so it kind of got me thinking here. We started off talking about firewalls, and we brought routers into the picture. And now
switches play heavily in that too.
Switches play heavily too. So everyone, of course, is familiar with the Cisco Nexus 1000B, which historically has been only for VMware environments. I just read a news release last night that they've already ported it to Microsoft Windows. So if you have a Hyper-V cluster, you can integrate Nexus 1000B with that now, and they're going to be extending it to other hypervisors also.
They did it for the Hyper-V 3, not 2.
Interesting.
Hyper-V 3 has the extensible vSwitch. Hyper-V 2 does not.
Right. And there's also the Open vSwitch, which is an open source initiative to do a similar thing that doesn't currently play very nice with VMware environments, but that's another option for segmented
I've gotten it to work
networks.
pretty well by using it in a workstation and then using that for my VLANs and stuff like that, and then applying that to the ESX.
Yeah, you can do vSwitch. You can use the Open vSwitch as long as it's part of an existing VM.
Yeah.
Yeah.
Don't have to bridge it between VMware's vSwitch capability.
Yep.
So it becomes a bump in the wire to implement Open vSwitch, which is what Nicira does for OpenFlow.
Yeah, and at that point, you probably are going to start looking at changing the architecture of your network.
Exactly. So if you're going to be looking at OpenFlow because you have a need for that, you don't have enough VLANs or something else, other resources, then you're going to re-architect your network anyways.
Yep.
But if you're just moving from a physical environment to the virtual and you want to make as little impact as possible, and this is what these guys really were talking about. When you look at your firewall, you can put an edge firewall where you have an edge firewall today, whether it's a virtualized one or a physical one, that can still work. Would you guys agree with that?
Yes, I would agree with that.
Now, but we both know that virtualization we all know, all four of us know that virtualization has one extra piece of capability that physical environments do not have, and that is the introspective firewall.
Mm-hmm.
Right? We can do an edge firewall, like in an edge device of any type of edge security or routing device. And then we can do the introspective firewall to add yet another layer of defense and depth before you even hit the virtual machines.
So by introspective, you mean hypervisor-based. Is that correct?
Introspective, hypervisor-based, yes.
Okay. Yeah, absolutely.
Zen, KVM, even Hyper-V has this capability. vSphere has it through the VMSafeNet or the vShield app APIs.
Mm-hmm.
And those all work. So hypervisors can give you more security, and you can use existing security measures that you already know and love.
If you protect your hypervisor, because remember that now everything depends on the hypervisor itself being secure. So you have to really protect your hypervisor. Right?
Yeah, absolutely, you do. Now, when we start talking about a network, we start ignoring the introspective, because I actually found something interesting about that. We can get to that.
Yeah.
I have to have multiple networks anyways in any hypervisor, whether it's Hyper-V, Zen, KVM, or vSphere. I have a management network. I may have a live migration vMotion network. I may have a fault tolerance network if I have that capability. I definitely have a storage network of some form.
Yep.
And then I finally have my workload networks.
For your computes. And there might be more of those, too, based on if you want like an HR one, an engineering one, or production one, for example. Yep.
Because there's no magic potion that says you have to have a firewall just on the perimeter.
No, you shouldn't. So when you say protecting the network management component, that becomes a rather intriguing conversation, because I'm a firm believer in putting all management behind its own firewall with jump machines. So I only allow RDP through that firewall.
So that's a good point. Now, I think we can talk about it now. We've shown some common, I guess I can say, attacks for management traffic on VMware, especially if you're not replacing all your self-signed certificates, right?
Yep.
And it's what you just said about having a jump box is a very important point. So when you set up an ESX host, typically you might go to your laptop or something and start configuring it, right? And then you got to build Virtual Center in a new environment. But if you can make all the management traffic go on that one network, you might not even need a gateway, and you use a jump box to get into vCenter and all the other things.
This is exactly what I and Ed have been preaching for the last 5 years.
Yeah. But that still doesn't control or log the access, and that's where the high trust appliance gives us that additional ability.
Well, yeah, those are nice things as well, of course, but
more granular.
Really good start.
I mean, the lowest hanging component of virtualization security is to protect the management network. But we've all talked that one to death on this podcast. So I'm actually want to concentrate on the rest of it.
Okay.
And that is that we all know about high trust, and we believe in it, and we all talk about it, and there's no problem with that. So I want to talk more about the other side of the defense in depth. and that is it's not really about just networking anymore. And the reason being is that the introduction of various introspective APIs move things so deep into the hypervisor that packets go through ways that cross boundaries we never knew before. For example, with vShield Endpoint and vShield app with data security, they tie into the storage layers to get a better throughput. And then with those storage layers, they bridge to a virtual switch port group.
That's kind of like a pass-through. Is that PCI pass-through? Is that what you're talking about?
No, it's not pass-through at all. This is actually how Endpoint works. Endpoint goes through the storage, basically the SCSI driver inside the VM, the virtual machine manager, sends the data over the network to another VM. The VM does all the heavy lifting. You can pump cores in it to your heart's content. It does all the antivirus, anti-malware, all the verification and all that, sends it back a yes or a no, and says, yeah, you can make that right, or you can make that right.
It's doing it once, which is the big benefit.
Without doing it once, and it caches it, and it's doing it once for everything that's of like operating system and so forth. But that actually binds your normal storage mechanism, even if you're using Fibre Channel, to go over a network connection inside the hypervisor. And granted, there's one per host, so you can limit it to just that host, which makes it rather intriguing when you think about defense in depth.
Mm-hmm.
So, let's take that DMZ case that we talked about at the very beginning. Normally, in most cases, I would say, you do not need a separate cluster for your DMZ unless that just makes you feel more comfortable from a political standpoint. Because where you put your virtual firewall would be the same place you put your virtual firewall regardless of where it is. Right?
Yeah. Everyone here will buy that, but when he makes a mistake and makes a wrong connection, loses their job.
And then that's where you need other tools like a high trust or a reflex or a Juniper VGW or a Capper to have tagging capability to prevent you from making that motion.
Okay.
Right. So that you do need that type of management control.
Right, and that's a high-level control.
Moving things around badly.
Right, that's a high-level control. That's not a network level. That's a more high-level management operations control.
Exactly. It's an operational control that absolutely needs to be there to alleviate the problem that Tim just brought up. So I'm fully agreement there. But that doesn't mean I can't have my DMZ in the same cluster as anything else.
That's
same
correct.
Cluster of hardware.
Mm-hmm.
Right? It's a comfort issue more than anything else.
That's right. And it's a CYA issue more than anything else.
Well, I think it actually adds more complexity to the situation because now I have to protect that management construct, that storage construct, that vMotion construct, the DMZ construct. Now it's segregated and separate, so I need to think about how I'm going to protect that, integrate it into my existing environment. And it actually adds, I think, a bit more complexity.
Yeah. There's no question about that. You're going to have to deal with, everything you said. Exactly. And let me mention one thing that I had a guy in my class come up with that was just cool. He created this was the guy that worked at a nuclear power plant. I won't name the nuclear power plant. But he came up with a way of taking all permissions away from a particular user except the permission to make the connection. Only 2 people in the company had that permission.
Yeah, and you can do that with role-based access controls and vSpot.
Exactly. So, high trust is wonderful, but Band-Aid fix for a cheap fix, that's a possibility as well.
Absolutely. Role-based access control, absolutely necessary. And you can now do it on network devices to say, you are the only ones able to see this virtual switch.
Exactly.
If you can see the virtual switch, or the port group, for example, if you can see the port group, you can put a VM on it.
Yeah,
unless you have some other preventative. So, yes, that's absolutely necessary as well.
It's kind of, as my wife says, si mira no toca, which in Spanish means you can look but you can't touch.
Nice.
You give them read-only so they can know it's there and so forth. Again, but that's more of a management construct, and I agree it needs to be done. But what else can we add to? We know we can add introspective firewalls into the network. What else? What else is there that we should be looking at or considering?
Well,
so
we should be
I got to put a plug in.
That what they are talking to is what they're supposed to be talking to.
Okay, hold on.
I was just going to put a plug in for the Center for Net Security benchmarks. We just updated the benchmark to 1.1, and it was released last week. It has a whole list of things to check. A lot of them you guys are covering already. And then for VMware, at least, it gives examples of how to check it and audit it and set it correctly.
Even, could you send me an email on that if you don't mind? This is Tim.
Yeah, I'm looking for the Twitter. I will send it out, and we'll see if we can't get Ed to post it. It has some links also, Ed, to your book, where you have a lot of good information on this same topic.
Oh, thank you. I'll definitely give me a look. Give me an email. I didn't even know the 1.1 came out, and I'm on that mailing list.
Yeah, that's why I'm looking for that. I'll send it out shortly. But I just wanted to give a plug for that because it definitely has a lot of good information there. One of the other things you mentioned was sharing trust zones. If you're using link mode, you want to make sure to have separate, that you don't share that across different trust zones. So say your firewalls in the DMZ are very sensitive for management. You don't want to have that sharing a data store that's using linked mode files with
I think we'd all agree.
Our
whole point is it's easy to make a mistake.
Yeah, but it's also easy to architect a design where you have separate data stores, separate port groups, even vSwitches, and you can put these into folders too to easily apply permissions to lots of port groups or vSwitches at once.
And it requires some pre-thought.
Some design,
right? Let's take this one step further. So, right now you're advocating. So, for example, the legendary DMZ, that all the VMs for that DMZ should be in its own set of data stores.
So there's a whole
set of data stores should not be shared with any other type of data.
There's a stack of things that should not be shared, and that goes from the port group. You would have a dedicated Active Directory security group assigned to that, so that only people in this group have permissions on this stack. And the stack involves port groups for the network, possibly vSwitches if you have enough sufficient physical network ports that you can have separate physical ports for secure traffic, user traffic, and say vMotion and storage. That would be ideal. But a lot of new systems are 10 gig. They just have maybe 2 10 gig ports. So you have to use one vSwitch and separate port groups.
Right.
So then you apply the security to the port. Right. So network storage, of course, the data stores, it is important to have separate data stores because that's how you apply the permissions as far as who can maybe copy or even see the VMs in those data stores. If I could get a copy of a firewall VM, then like that attack we were talking about, I could get the VMDK and then start looking through it, and I could find, the SNMP community string that allows me to read or write to make changes. I could probably hack the password, things like that. So you want to protect those firewall VMs or your switch VMs.
And unless you're using SNMP version 3, that's an entire problem.
Yeah. So data stores, networks, resource pools is another one. You want to make sure that you don't get a denial of service situation where say a user group has the ability to create VMs on your ESX cluster, and you're sharing that ESX cluster with your firewalls, let's say. If they could just create so many VMs that they overload the ESX server, then the firewalls could not have the resources that they need to function properly.
Well, we can avoid that with fixed reservations.
That's what I'm talking about, resource pools. So you want to have separate resource pools for all of your VMs, not just your secure VMs, but even the non-secure VMs should be in a resource pool so you can throttle down the reservation.
For most important VMs, you can even go with fixed reservations. So VM is always assured to have enough resources to run.
Exactly. So let's step back a second. We talk a lot about vSphere here. How would you do these exact same things on Xen, KVM, or Hyper-V?
That's a very good question.
With a lot of work. Right now, I don't think there's a uniform way.
Is that in KVM do iSCSI shared storage? You can actually have different iSCSI presentations for different security zones.
So as far as I know, VMware has done a really good job as a vendor of releasing a hardening guide that gives a lot of good advice. And I don't know that the same things exist for Zen and KVM.
Citrix Zen, yes. Red Hat has their own as well for KVM, but the public ones, not so much.
Right. Okay. And then
Hyper-V, but if you think about Hyper-V 3, not Hyper-V 2, but Hyper-V 3 with the extensible vSwitch we've already talked about, like the Nexus 1000's going in there, and the Open vSwitch is already in there with Nicira built in if you wanted OpenFlow. And they actually added into their vSwitch some more security constructs that are just
what's the last one you're talking about?
Hyper-V 3.
Oh, nice.
They actually added quite a bit into their networking stack for Hyper-V. And on top of it, they have actually added into Hyper-V native BitLocker encryption at the hypervisor level. So you get the encryption of data at rest. This is below the VM, but above the storage. And then they've added in DHCP guard and a few other things. They've actually got some really nice native networking and some storage security built into it. But even so, you still need, I think, more defense in depth than that. Would you guys agree?
Yep.
So how would I do what you were just talking about even in those other hypervisors?
So we need to get a benchmark made for those, and I'm not sure that an industry-accepted benchmark exists at this point.
Now, Edward, are you talking about how can we be sure that nobody is mucked with it? And I'm using M-U-C-K, mucked with it. Or are we talking about if somebody loaded something before? Or can you specify, please?
Well, actually, I was just saying, defense in depth for vSphere, I think we've all understood. You can do physical edge fire. You can do between the vSwitch, bump in the wire firewalls. You can do even external firewalls, which will work with any of these, by the way. You can do introspective firewalls, which only exist currently for vSphere. And then you can do firewalls inside of the VM. So firewalls have 3 layers and places they can put them. In Zen and KVM, there's 2 layers, which is a bump in the wire again, and then the bump in the wire beside. Actually, I think Catbird supports Zen right now. Zen or KVM? Actually, I think it's KVM, actually. Either way. And then you can put a firewall within the VM again. So firewall protection in Zen, KVM, and Hyper-V kind of looks very similar to what you would do in the physical network. Would you agree? There's not much difference there.
So there's no introspective firewalls on KVM at this point?
I don't know of any that have written for KVM, Zen, or Hyper-V.
I thought I read something, but I may be wrong.
I've read a lot about people thinking about it, but I haven't seen a product yet. Now, I could be mistaken, and if anybody knows, please just send me an email or send me a tweet and let me know if I missed something, because I'd be fun to know.
The exact question was what now, Edward?
Are there any introspective firewalls for any other hypervisor besides vSphere? In other words, it's tied into the kernel, to the hypervisor itself. For example, Viata in its firewall and a smooth wall on IPCOP, those types of firewalls are actually VMs, the virtual machines that run between 2 port groups, 2 virtual switches.
Yeah, so you have to force the traffic through the firewall in order for it to see it. And
you have to bridge
inter-machine traffic, so traffic between VMs on the same host, don't go through the firewall necessarily.
Well, if they're on the same switch construct.
Right.
Yeah. We all know that. With introspective, you're always hitting a firewall as soon as you hit the virtual NIC, effectively.
Exactly, because it's inside a hypervisor. I guess for it to exist, those other hypervisors should have the equivalent of VM-safe APIs, and I'm not sure if I've seen any.
Well, Zen has them.
Zen has them? Okay.
Yes, absolutely. Citrix Zen Server does have it. And Hyper-V has APIs you can use to do the exact same thing.
Okay, then it's only a matter of time before somebody does an introspective firewall for those guys.
Exactly. But do you know of any? Does anybody know of any right now that are because introspective for Zen has been out for years. It came out 6 months after VM-Safe.
I know that a lot of the vendors we talked to last year about virtual firewalls that run VM-Safe were looking to port their products over to work with KVM on either Ubuntu or Red Hat, and also looking at Zen. And they were asking us as a customer, which do you think we should work on, and they're taking surveys basically. Now, that was a year ago. I haven't really followed up on those, but I know that they're talking about it, so we should see
I know there's a lot
soon.
of talk about it. I had the same questions, by the way. So firewalls aside, so we've covered the firewall situation fairly well. Let's think about everything else. We've covered role-based access controls fairly well.
Mm-hmm.
Let's look at storage. And the best defense in depth we can think of for storage is basically to say for each trust zone is to segregate your storage, your data stores, or where your VMs live from each other. That makes sense.
Right.
And for some of those VMs, it's actually worth encrypting them somehow.
Mm-hmm.
And we talked about that on the last podcast. Now, what's interesting about Hyper-V 3 is that BitLocker is now for the data stores, is actually part of Hyper-V 3 now.
So is that for inline real-time encryption?
It's data. It is of the data store itself, not the individual VMs, except where the VMs live on there. And it is at the hypervisor level for the whole data store, which is kind of nice.
Interesting. I guess VMware doesn't have an equivalent for this.
No, VMware nor Zen nor anybody else has an equivalent for it. They have to use it's something in the hardware like a self-encrypting drive, array. The controller for the storage could do the encryption. You can have an encrypting fabric switch. You can have an encrypting HBA or an encrypting NIC.
Then we're going to have to deal with all kinds of key management issues.
Well, then all along you have key management issues no matter how you slice it. And again, if anybody's interested in talking about key management issues with encryption, please listen to the 2 weeks ago podcast when we had high cloud security on, and we covered that fairly well.
Right.
So what else is there we can do with storage other than segregating our workloads based on data store? Is there anything?
Well, there's also prevention of, preventing user mistakes of putting VMs on data stores where they don't belong. And that can be done with policy-based management.
Policy-based management, applying some form of tagging and so forth, okay?
Yes, that's what HITRUST does, for example.
Exactly. We've mentioned previously.
Right.
It's more of a proxy, I think, though, right?
Excuse me?
It's more of a proxy, though, right?
Yeah, so HITRUST basically intercepts all of the management calls and applies policies to those. So we can catch mistakes like that easily.
Okay.
Okay. So we got that. As long as you have the proper tags applied, you can catch them.
Absolutely.
Okay. And there's other companies that do the exact same thing, Tim. What do you guys do when you virtualize and have multiple trust zones?
Okay, so one of the really basic things you can do to secure your storage, and it's a little unintuitive, but it actually works for larger environments that have application redundancy, is not use shared storage. If you have dedicated local storage on your hypervisors, then it's very difficult to attack someone else's storage. You're limiting the exposure just by keeping the storage local.
Mm-hmm.
But that may not be practical in a lot of situations, right? Because people do want to use shared storage pools. It's in a lot of data centers that's a requirement.
Mm-hmm. And given some of the things that Dell announced this week at the Dell Storage Forum, shared pools make a lot of sense.
So if you're going to use network storage, or shared storage. Fiber channel, of course, offers security controls which can be enabled. The zoning can be put in place, and a lot of SANs have that feature.
You can do zoning and presentation regardless of whether you're fiber channel, iSCSI, CIFS, NAS, SMB, whatever.
And then if you are using iSCSI, this is one of those that I actually had to read up on, but it's in the benchmark as we were working through it last week. Ed, you probably know the details better, but it has to do with the CHAP and the passwords. You want to have each ESX host have its own iSCSI password, and make sure you use bidirectional so that it authenticates both ways.
Mm-hmm.
Unfortunately, CHAP is used to access the first time, not every time. So once it's connected and has permissions to connect, everything else is in clear text.
That's correct.
So a man in the middle can still be done. All you have to do is wait for CHAP to finish.
Exactly. And I've proven that many times.
So while it's important to do that, you got to realize that things like having encrypted HVAs are probably a lot smarter for IPsec encryption of the iSCSI traffic or doing IPsec with inside the host.
Mm-hmm.
But if you do that, you need better have Westmere, Sandy Bridge, Ivy Bridge CPUs because they have the AES and I encryption offload in the CPU. Right?
Mm-hmm.
Because if you do it native, it adds like a 2 to 5% overhead versus doing it in a CPU, only in CPU or only in instructions, which would be a 50 to 60% overhead. I don't know if anybody's run a test of using Westmere chips for iSCSI encryption yet with IPsec. Have you done anything like that, even?
Not me, no.
I haven't either. It's actually maybe worth trying. Because then you'd be able to encrypt from the hypervisor all the way down. Well, at least data in motion. So, you're right. CHAP, absolutely, but that's only on the initial mount. You still got to protect the data some other way.
Mm-hmm.
Yep.
So what else are we thinking about here? I'm still trying to run through it. Encryption is big with storage. We know that. Okay, we've gone through that.
Okay, where is your data? Jurisdiction.
Well, we've also talked earlier about making sure the data store that you're putting your data on is only for that classification of data.
Oh, okay. And so naturally we have our SLA to back that up. So the SLA, those guys would never lie to us on that.
Well, not thinking just cloud, so.
I'm playing devil's advocate, of course. I'm not trying to be mean to anybody, because SLAs, they very well could be 100% honest, but you just don't know. I just really feel like there's got to be some kind of checks and balance that we can call for immediately on the fly whenever we want.
You're looking at cloud audit.
Exactly.
Yeah, that's what it sounds like. Speaking of cloud audit, one aspect, I usually bring up is data replication. A lot of people are doing this, right? There's redundant data replication, data being spread all over various data stores and so on. Do we have any controls over it? How can we make sure that not only it's replicated to the appropriate data stores, but when the user deletes the data, it actually gets deleted everywhere?
Well, not only that, we'll think about how the hypervisors do deletes of virtual machines. All they do is get the entry out of the table of contents.
Right.
They don't actually scramble anything. They don't delete it. So the data is actually still on the VMFS.
Yep.
Right.
Or on any file system. It could be an iSCSI or NAS or SMB share or whatever it is. It's still written there. So there's no DoD wipes going on at all by any of these hypervisors that we mentioned.
Mm-hmm.
Is that something that VAAI can help with?
VAAI, when you delete it, it just deletes it out of the table of contents as far as I know.
Yeah, it's just like operating systems. It just deletes from the table, but doesn't actually wipe it clean. Doesn't do a shredder kind of thing on it.
So that
now VAAI does have a zero block request. so that when you create a new VM and it's a one that is zeroed already, you can actually say, give me a bunch of blocks that are zeroed, and that will happen at the array level. But during the delete, no one's actually done that, as far as I know. And you think about this, VAI now 3 has ODX, right?
What's that? Which has what?
Micro has support for ODX, which is another form of VAI.
Okay.
Welcome, Michael. Sorry, didn't get to see you log in as soon as.
Well, there's a good question for Michael. He'll know the answer that we were asking earlier. Michael, the question we had, are there any introspective firewalls for anything other than VMware?
Hopefully.
Nothing I can disclose at this time.
I like that answer.
I like that.
But sure, there will be.
Okay.
You know, it's a customer demand. It's a customer demand situation. There's other platforms where there could be.
Sure, that's fair enough.
You know.
Mm-hmm.
But I'm interested. I think you need to tie the encryption conversation you were having when I joined to this deletion conversation you're having now, because a lot of in my opinion, a lot of the deletion problems go away if fundamentally you're encrypting at rest in the start of the whole process.
Exactly.
But you also need to encrypt at rest not only the virtual disk, but any other metadata files like snapshot files and memory files and configuration files.
Yeah, it's a lot of stuff to encrypt and eventually delete. It's not as simple.
Yeah, and I don't buy that we just need to encrypt and not have to worry about delete, because by today's standards, that's true, Michael, but it's not necessarily true by tomorrow's standards.
Yeah, quantum computing is coming.
Yeah, one person at a time. Michael?
Well, no, he said it, quantum computing. Whether it's quantum attacks or, just straightforward, flaws discovered in, existing protocols. I'm aware that, there's a new version of DoD approved SSL coming down the pipe sometime soon. I know that there's been some tweaking of the algorithms because of, I'm suspicious because of attacks nobody knows about except certain agencies that specialize in these things. Mm-hmm. And, there's stuff out there, and we've seen it, right? We've seen it with publicized attacks that certain algorithms that were thought to be secure 10 years ago are now known not to be secure.
That is correct.
And that's a problem. There is data. My medical. I don't care so much about my medical data. I told all of you guys about my knee problem, but I'm just saying, in general, other people feel differently about their data, and certainly the sensitivity of that data has a lifetime of far greater than 10 years in many cases.
Mm-hmm. And now you've just told the whole world. Very good.
Yeah. Well, I'm okay. I'm okay sharing the fact that I'm having knee problems with the world. I mean, that's okay. But there are certain places in the world where, there might be things in different people's medical histories that they don't want to share. Or, I know that's the case. None of us want to share our payment card data. But did you guys discuss, in this whole cloud security model, I'm still very doubtful about the user endpoint. Did you already cover that?
No, we covered the user endpoint about 4 shows ago. But right now we're just talking defense in depth for various measures. We've hit networking pretty heavily, and now we're talking about the storage defense in depth. Yeah. And I actually
talking about field edge. You touched on that when you're calling endpoint, but that's it.
Well, I agree with Mike that I think encryption is tied to delete today, because you can encrypt your data today. When you do a snapshot, it also is encrypted today. And that's regardless of the hypervisor you're using. Any type of construct that touches the virtual disk, as long as you're encrypting that virtual disk, will stay encrypted. So
yeah, there's really no trusted way to prevent your data from leakage if you delete it or exit a cloud provider, right? Other than encryption.
Exactly.
I don't know of any other way. Unless you maybe reinstalled a new operating system on it and did a wipe of some sort before you deleted it.
Well, you could always boot it up under a CD. What was the name of that CD? It was the UDA.
Yes, sort of
deployment
ultimate
appliance. You can
right.
You can actually import that, and then you can do a DoD wipe of your virtual disk.
Right. I wonder how many.
The virtual machine.
Wonder how many customers do that though.
Well, and even I'm not even sure that works. I mean, I learned a long time ago that with modern file systems and modern drive arrays, you're only wiping the most recent storage locations.
There's snapshots, exactly, backups to worry about, and you can't really go in and you don't know what unless you're sure. That's where I come back to local storage. From a security perspective, local storage is definitely the easiest to protect and most secure. It's just less complicated, right? You have less functionality.
I don't know about that. Even with local storage, you have you're always still doing backups. You're still doing replication, perhaps. You know, you got a hot site out there, possibly moving things to. So the data there's a proliferation of data. Let's say we have a single machine. I bet you'll find it in 10 different locations.
So there's a different way of thinking about when you start moving to cloud. There's a different way of thinking about your machines.
Right.
Before cloud, your machines have names. You need to back them up and protect them. But what more and more customers are finding is now with cloud, you can have more machines spread apart different places. So you protect the data in that one machine, or you have a pair of machines, one in one data center A, another in data center B, and they don't necessarily need to be backed up the whole machine anymore. So enterprises probably do just have big machines that they protect these named machines, the email server, the web server, for example. But as you move towards cloud apps, you can just have different servers and delete the data.
Some of our cloud service providers are providing us ways to, leverage the deduplication and still provide encryption, but that's a little tongue-in-cheek too.
Well, you're talking about Dropbox and Box.
Not necessarily. Dropbox does it actually, but there's tools you can add on Dropbox to do it. I'm talking about things like Bitcasa, where they guarantee the encryption. But the way they do it is they do an encryption, create the hash, store it as metadata, so that way, even though it's encrypted, somebody else who has the same metadata has your same file. So let's say, for example, there's Michael has a copy of, let's say, the BitLocker, okay? And I also know I have a copy of it. Is Michael's legal? Is mine legal? We both know we have a copy of it. Where did we get it? So is it truly encrypted?
Well, that's a different. That's a fallacy of some of the encrypted storage devices. But when I talk about encryption, it's I own the keys. No one else does.
Well, yeah, that's an important point. I think that's another aspect of the cloud that when you talk about data custodianship and where is your data in the cloud, some of those problems go away if you maintain ownership of your keys.
That's correct.
Right? Even for like EU conditions, if you're an EU entity and you hold the keys and the data is encrypted in motion and at rest, it may not matter where in the world that data ends up. And similarly, as a U.S. entity dealing with patient health care or other kinds of data, I would almost argue it's negligent if you're not encrypting and holding the keys. That would be my considered opinion.
Mm-hmm. Well, yeah, that's why a lot of these sensitive apps haven't moved to the cloud or not even virtualized in many organizations.
Yeah.
Yep.
And
okay.
It all basically boils down to where do you want to start your trust?
Right.
That's what goes on.
And if you own the keys and encrypt everything yourself, or you have encrypting files,
the whole internet key system or the whole internet certificate is this vouching system we used for forever. It's like, for example, when we were very, very little, we were told as a little guy, okay, now by somebody we trusted, now you could sit on Aunt Sally's lap, or for God's sake, sit on Uncle Billy's lap. we were told that by somebody we trusted. So consequently, that's what we did. That's exactly what we're doing with the certificate authorities. But if the certificate authorities we can't trust, then the whole dilemma goes awry.
Well, right. That's a big problem, and we as a community and industry need to solve that, because for the consumer, that's a huge, huge issue. For a larger entity, even my tiny company, we have our own CA.
Exactly. I have my own CA that I trust.
And most people do as well.
See, I like the way that you guys do it. The way you guys do it with Catbird is you either trust a root level authority or you trust a certificate that is signed by Catbird itself. That way you don't force the client to go out and buy a certificate.
Oh, but we also allow them to do that.
Yes,
or to have their own CA. I think you
do it either way.
And I'm sure I'm sure others do the same thing. I mean, that's just what you have to do. But I think for consumers, I use my, I'll use my sister or my mom as an example. They can't do that. They're not going to run their own CAs. So what you just said, Tim, really applies at the larger level. That this ongoing issues we keep having with the bigger CAs is just ridiculous. I think wasn't GoDaddy the latest?
I would like,
we're
almost at the end here, but I want to know how hard it is to become your own CA, that you actually publish it on the internet.
OpenCA.org.
But a trusted CA where, you can get your cert exactly.
Yeah. It's
how do I get Chrome, Firefox, and IE to get my root certificate?
Hold on a second, Tim. Let Eben finish.
Okay.
How do I get Chrome, Firefox, and IE to accept my root certificate?
All of them accept over 248 certificates. Who makes this decision?
Microsoft. I want to be 249.
Okay. Then I'm going to send you this document, all right, as soon as we get off of here, that will alarm you.
All right. That'll be a good topic to have. It's all about trust. I agree with Michael. The more you can do to sort of own your own environment is better. So whether it's your keys, your DNS, your registrar, your CA, that would be fantastic. And if you are able, so say you don't have a trusted root cert in Microsoft's web browser, Firefox, and Chrome, you can still issue those to your customers. So the government does this here in the United States. If you want to do business with the U.S. government and you're trading data securely, you actually have to purchase a certificate, install it on your browser at your desk, and then connect with them and publish your cert with them, so you have a two-way trusted communication between your browser at your desktop and the government website. This is just to place a bid on a contract with the government.
Right, and what that is basically a pre-shared certificate.
And it's a very cumbersome process. I mean, how many vendors are going to go out and spend $100, $200 a year per computer to be able to submit a bid to the government? A few big ones do, and that's how the government does business with those guys. But how do we make that easier for cloud customers to do? More practical, right?
You need an independent trust authority.
So Ed,
or a cloud provider. Sorry, go ahead.
I was just going to ask Ed one more time. What's the name of that? If I want to have my own CA, what's that called?
OpenCA.
OpenCA. Okay.
.org. It's
Michael?
You can get it as a VM. You can get it as software.
I was just going to say, I mean, it makes sense, and I'm still wondering why my bank doesn't do this, but it makes sense that your cloud provider, your bank, should give you a cert. My bank should give me a cert every year for free.
Well, maybe they just don't know how. So this OpenCA thing, the bank would set this up, and then they could issue certs to you, right?
Yeah.
Well, actually, some banks in Europe, for example, will issue you a token, and you have to get it renewed every year. So for certain businesses, you can get that level. For individuals, I haven't seen it yet.
Yeah, and they also offer what's called a scratch list. And that scratch list means that you use this password along with your regular password, and you have to use the next one on the list. And so there's lots of ways to do it.
Yeah. you're right about that, and I'll tell you something that came up that just frustrated the heck out of me with this LinkedIn break-in. It's just such a tragedy that we're using passwords, and I have to give props to Google and a few other organizations, because you as a user of the service can just say, I want to turn my phone into a token. And so when you're using their service, you can opt, and actually this is something my bank does as well, so they're not terrible. They'll send you a text message, and it'll be a 5-digit number or whatever, or 8, I forget now. And the bank uses 5 and Google uses 8 or something. But anyway, you get a number, and you have to punch that number in.
And what's wrong with that?
There's nothing wrong with that.
Exactly.
Yeah. The other thing I was just going to say, I have a credit card that works in Europe, and what that means is I've got a chip and PIN on my credit card.
Exactly right.
So the technology actually exists, right? We could put these pieces together, and passwords would not matter so much.
Right, and we can put them together cost-effectively, inexpensively, and easily.
Yeah. We still have the problem of, it's trivial to get a keylogger, onto someone's computer, but we could at least make it less useful.
Right.
Well, some of these solutions like RSA tokens have existed for years, and they haven't really taken the world by storm. I suspect a lot of people still find them kind of cumbersome. And I think that's probably the answer why it hasn't been widely adopted, or more widely adopted than it is.
Well, I think you're right, but there was a price there, and I'm sorry, I'll give up the floor in 1 second. But I think, Boris, and I could be wrong because I live in a bubble, right, a technology bubble. But I think there's the intersection of smartphone users, at least phones able of accepting that, SMS message as a secondary token, and internet users. I think that intersection is almost, unity. It's almost everyone, and therefore you don't have to sell them they don't have to buy a secure ID card from RSA for whatever that costs. They already have it with them. So I think we, the providers, folks like us, we just need to be demanding that, hey, everyone's got a smartphone. They certainly have a phone smart enough for an SMS message, and just require that. Make it happen. That's
so we're at the end of our hour, and it's been a great conversation. So, Boris, last thought?
So I think we've covered a lot of ground. Firewalls, storage, end user. I think all that is, and we still left a lot out, like IDS, IPS, application level protection, and so on. Data protection is definitely, I feel, is a huge issue, and with the cloud, it gets even bigger. So I wonder if we need some new ideas. For example, I wonder if somebody would try a sort of BitTorrent kind of approach where data is split into a lot of small chunks and spread out. So even if a data store is compromised, it only has a small portion of somebody's data. So perhaps some new approaches out there needed. But it's going to be an issue for years to come, I feel.
I agree.
Stephen?
Yeah, I think it's interesting. I learned something new, or many new things on these podcasts every 2 weeks, and I just keep wishing there was a guide for what we learn on this podcast. So we should go back and make a book about this or something.
There are some podcasts that are available that they actually what's the word I'm trying to think of?
Transcribe.
Transcribe. Thank you. Transcribe them.
Transcribe, yeah.
Of course, that's expensive and stuff too.
Well, maybe it'd be worthwhile listening to the last few that have even come up on this call and sort of doing a review or a summary. And we have I could take notes during it and kind of make a hit
I write about them if you go to the virtualizationpractice.com. I actually wrote about the last 3 have been written up already.
Awesome. That's what I'm looking for, because there's so much we learn, and it's like, where do you begin on this defense in depth? You got to start with the simple things that you know and that you can quick wins, but then you should be looking at the big picture for some of the bigger things, the initiatives that you can put forward within your team. And
it's pretty much
for those.
What will your people do? There's a fine line between, I always tell my classes that security is like one great big yardstick. Ease of use is at one end of it, security is at the other. You need to find the happy medium where they're not lighting the torches and chasing you through the village, ready to crucify you when you make your password 20 characters long.
Yeah, definitely it's a balance, so you got to be flexible and adjust it. But at the same time, you can take a threat-based approach if you know where the attacks are coming from. And that's where this podcast helps a lot, so we can see some of the real-world things people are saying, what's becoming more and more practical to do. We wouldn't have thought of encrypting virtual machine disks a year or 2 years ago, but now it seems like it's becoming more and more mainstream and it's possible to do. So I like to hear that kind of stuff.
So, Michael.
Yeah, I mean, I think what I would respond is to follow up on what Eben was just saying. And Boris, by the way, I think I can't remember the name, but I think I've seen products that spread data around intentionally to fragment it in that way. And
Interesting.
Yeah, I think there's already somebody doing that. One of the other 800 security companies. But to follow up what Eben just said, I back in the day when I did, CISO and security professional services consulting, I said exactly that. What is the easy thing to do? Where's the quick win? And, nowadays I would basically say, SANS does a great job of this thing called the top 20. Do you have number 1 working? Do you have number 2? Can we get the top 5? And, that's how I would recommend to people because, if you don't even have, 1 and 2 working from the SANS top 20, you'd probably... That's
a good point. There's actually an RFC, if you guys remember back to the day, about securing your IT, like a security handbook RFC. Right. You guys familiar with that? And it was very interesting for me to read the intro to it where it said, although many of your teams are not connected to the Internet today, here's still some things you can do as you approach the Internet age, right? And it's kind of like we need to update it for the cloud, right? Although many of you are not using the cloud today, here's some things to do. And take that old RFC and update it for the cloud. That would be awesome.
Well, I have to say, if you're not using the cloud is using you. I mean, it's just ubiquitous. People don't realize it.
Yep.
You may not be intentionally using the cloud, but that was the other thing I was going to say. This is a whole other podcast that's kind of outside my field, but I've gotten really interested in it. It's the BYOD. I mean, the iPad is here. It's here to stay. And
okay, hold it, before we go on to that, let's make that another podcast because we really are past our time. And I look forward to talking with you guys again in 2 weeks. Thank you very much, everybody.
Right. Thanks, Ed.
Thank you.
I just didn't want this one to end, man.
Okay.
It's called the Site Security Handbook. It's RFC 2196.